We look at this section on volumes between two curves, and we're looking at cross sections, and this section is mainly doing squares and rectangles. One thing you want to keep in mind, and I wrote down some notes that I have no idea where I placed them now, because this was the extra blank copy of them. Hey, there's the filled-in copy. I was working on some of the other notes for the rest of the week today. So one thing you want to keep in mind as we get ready to start this problem here, some things we want to keep in mind is which direction are we perpendicular to? Okay, that's the first thing we got to keep in mind. Are we perpendicular to the x-axis? Are we perpendicular to the y-axis? Because that dictates how we need to set up our formula. Okay, which one are we perpendicular to? All right. Then the other thing we want to keep in mind is the shape. And so today we're only focusing on squares and rectangles. Tomorrow we talk about semicircles and triangles. And that's to the extent of it. We don't do any other crazy stuff like trapezoids or rhombuses, whatever. It's just four basic shapes. And so we do need to make sure we know the formulas by heart for, and typically the one that we forget is the semicircle, is what a lot of people forget. Okay. So over here on the right-hand side, we have two curves. We have a region is bounded by the curve y is equal to x squared and y is equal to square root of x. And it forms this basic solid over on the right-hand side. And again, we can find the area between those two things. But they tell us that we want to find the volume. Each cross section is perpendicular to the x-axis, and it is a square. Okay, so it is a square. So over on the side here, what I try to do is give you a little picture here so we can try to draw some. But what we got to try to imagine, and again, I'm not the greatest artist, but if I draw a horizontal line or a line connecting the two curves, and then try to draw a square from there. And that's what we're trying to do is we have all these kind of infinite number of squares. Some are taller than the other ones because, as the curves get closer and closer together, then the squares are not that big. Right now I'm looking at a C- on my art class here. Okay. So obviously the squares in the middle of that of it would be the biggest squares we would see, but then as we get closer to the intersection points, we'd be really small squares. And so we're trying to find the volume of all of those areas added up, is what we're trying to find. What is each area for each of those little rectangles, and then we're trying to, or triangles, not triangles, squares, and adding up all those things to create our volume is what we're trying to do. So it's almost like taking a stick of butter and we cut like perfectly little cubes, squares, and then we just combine it for the whole volume when it's all said and done. So as we look at what we're doing, we're going to start off with our integral. We have from 0 to 1. It says with respect to x, so I'm paying attention to the x values for my lower and upper bounds, so from 0 to 1. And then now, when we look at the length of a side, the length of the side would be the top curve minus the bottom curve. That's the length of one of the sides. So the length of one of the sides would be the square root of x minus x squared. That's the length of one of the sides of the square. And then again, what's the area of the square? Well, it's a side to the second power, so that'd be that stuff squared. Everything good out there? What? In here?
Yeah, it was good.
I didn't know. How far did he get? I didn't even pay attention.
He walked here.
Sorry, I just sacrificed you all and get you all killed because I didn't pay attention who walked through the door.
You were really locked in.
I was locked in. This is like I gotta concentrate to make sure I don't goof up what I'm saying.
So, did you square it because that's a side?
I squared it because it's a square. Okay, it's a side and then square, because we know the formula for a square is side times side. Okay, as opposed to the basic base times side. It's side squared, or what it is. So that's why I squared it. We took one length of the edge and we squared it because it would be this times itself. And then, now you can put that all inside a parenthesis, another set of parentheses, and dx is fine. Okay, question?
Could you put the whole equation squared or just the inside? Like, could you also put the dx and the logarithm? Or not logarithm,
The integral? No, the dx needs to be outside. So that's where, like, if you're using Math 9, then, you would want to make sure this whole part right here is inside the parentheses they give you.
Okay.
So I would use a separate set of parentheses. I would let their parentheses be the outer border, and then I do parentheses and that junk squared inside their parentheses.
Okay.
And so that way there's no answer, but it's misreading what I'm trying to take the integral of. Okay. Now, on the free response, writing it, you're fine for doing that. Okay. They won't mark you on, like, being off on the formula without having that extra set and stuff on there. You're okay with it being that one. So now this one becomes our basic little Math 9 thing. So I'm going to get my, right there. And I have no idea. There we go. And then we go in here. And I didn't type in those equations, so we'll just go ahead and put them in real quick. So Math 9 from 0 to 1 of inside of here, we got the square root of x. Get out of there. Come on, get out of there. Minus x squared. And then I'm going to back up and I'm going to say, you know what? I need to square all that. So I'm going to put an extra set of parentheses in there. Ooh, it didn't like that. All right, so second insert parenthesis, and then get that x back in there. And then go outside of that power, and then put a parenthesis, and then now I'm going to square it. So that's how we'll type it in the Math 9, is like that, to where it's the. Otherwise, if you don't, it's not going to square it. So you got to get it in there before the dx stuff, inside of their parentheses. And then now we just press enter, and it gives us something like approximately, whatever, come on, pen. Approximately 0.129. I like rounding. Again, you can truncate in 0.128, but I like to round. Okay. So more or less, when we look at our formula, what is the volume? In this case, for generic sakes, it's the integral from a to b of the area, whatever your area function is, dx. Okay, that's your generic formula, where a of x is the area, where a of x is the area of a cross section perpendicular to the x-axis. Okay, so when we look at it being a square cross section, our formula is going to be basically our side squared dx, where s, our side, is f of x minus g of x. Top equation minus bottom equation. If we were doing it in terms perpendicular to y, then we would say right minus left. Still the same terminology stuff. For the rectangle, our formula, again, it's going to be our base times height, or width times our height. Width times the height, dx, where the width is our f of x minus g of x. And then on this one they're going to have to tell us what the height is. All right, they'll tell us that the height may be a physical number, or it may be something times the width. Okay, we see an example of that coming up in one of the things down here. You look at 3a, just the little foreshadowing. It says the height is 2 times the width. So whatever the width equation is, I got to multiply it by 2, and that's what the height of the problem is. So again, you're not going to have to solve for it. They're going to tell you physically what the number is. We got an example of that in our notes coming up. And then also, or they'll tell you it's so much times the width. Or plus the width, whatever, some altering of the width. So number 2 says same base as number 1, but the squares are cross sections that are perpendicular to the y-axis. So again, instead of drawing my squares, the short one, now on my 3D pictures, this is where it kind of gets a little bit tougher. But I'm going from I'm going from the black picture to the purple picture, or blue, whatever it is. And that's where I'm drawing my squares. So I'm drawing them, you know. Oops, I'm trying to get it down low because I think I was off the screen, but it was just because it was like cut off. So our squares are going a different direction there. So again, you don't have to draw yourself a picture. It just, you know, unless you're really good at art, then you can. But they want us to go from with respect to our perpendicular to the y-axis. So with that in mind, as we look at our equations, they started off with again, we had y is equal to x squared, and y is equal to square root of x. So we got to convert them over. So that would be x is equal to plus or minus the square root of y. And then over here, we would have x is equal to y squared. So those are my two equations. And then now, what am I going from? The integral from what to what? Again, going back to my position, even if I change over to y's, it's from 0 to 1, so the a and b didn't change. So it's still from 0 to 1. Now it's the right equation. Well, the right equation is that would be the plus the square root of y, is what that would be, is what that right equation would be. And so it would be the square root of y minus, and then the left side would technically be the y squared, is what that would be. So minus y squared dy. Okay. So again, I guess I could have done it here closer. Again, this is the plus the square root of y graph. This one is the y squared graph, is what that is. Again, y squared because our parabola would be like that. Yo!
So why did we square the one that was for question number 1, but not this one?
I haven't gotten done yet.
Okay.
Isn't that the y squared? Like, are those flipped or is that just me? Like, cause isn't that, you said that the square root of y was the y squared, right? Isn't that y squared, it's a parabola?
I mean this is y squared. When I do it in terms of x,
Oh, cause you're looking at it like different.
yeah, you're looking at it sideways.
Okay.
Yes. So x is, again, this is something that they've taken out of the curriculum. X equal to y squared is a parabola that opens up facing to the right. We used to do this a lot in Algebra 2 and Pre-Cal. Doing stuff in terms of x is equal to. And they just took it out of all the standards, and it's just, you know, so this is maybe the first time you guys are seeing that. Because we typically don't graph stuff in respect to y being the main variable.
So, it will always match, like, when it's in terms of x, like, y equals the square root of x is the same as x equals y squared.
Correct.
So they're the same line.
Correct.
So it will just always match that.
Yes. The difference is just the extra pieces for the plus or minus parts going into the extra quadrants. Is the difference there. So, and then again, we didn't have to deal with, but technically on this side over here, that's the negative square root of y, is what that one is. Okay, it's negative times the square root of y. Oh, because again, we're putting y values in there, so we can only put in y values. These y values can go in here, and that gives me negative x answers on that side. Okay. And then yes, as I got sidetracked with the switching pictures, and I left off the squared part, so I did get that squared in there. As I was drawing my pictures, I got sidetracked. So it's the square root of y minus y squared, that quantity squared, dy, and that's my area.
Can you, like, if you want to see which one is on top but you're not 100%, can you, like, plug in values same as with?
Are you talking about it on top,
Or
meaning
left
from
or right?
left to right? Yeah, you can put yes. If you pick a y value in your A to B.
Yeah.
And you put it in the equation, whoever has the biggest x value is on the right. Okay? And then whoever's got a smaller x value is on the left. Okay? So yes, just same logic that we did with the when it's who's up on top and who's on the bottom. Okay? All right. Far side, we doing okay? I'm going to nickname that side the comic strip. We're going to call it. All right, the base of a solid is formed by y is equal to x cubed, y is equal to 0, and x is equal to 2. Find the volume if the cross-section is taken perpendicular to the x-axis, form a rectangle. Oh, good, they gave us a picture. I didn't have to draw it. All right, so again, they tell us with respect to the x, which lets me know that I can leave my equation alone. I don't have to change it, okay? When they say with respect to y or perpendicular to y, then I'm going to have to change it in terms of x is equal to. Okay, so this lets me on part A, I can leave it the way it is. I'm going from 0 to 2, so that's my 0 to 2. We can see that the x cubed graph is on the top, okay? And then technically what's on the bottom? Well, we don't have to worry about that. We just have, that's our, okay. So we have, again, we're doing width times height. So my width, well, I would do technically my width to be really type A. That is technically my width. X cubed minus 0. In case I'm not using the y-axis, in case I'm using or the x-axis, in case I'm using something else. So it's x cubed minus 0 is technically my width. Now I have to multiply that by 2 times the width. So 2 times x cubed minus 0, because that's my height. And then that's dx. So we could clean that up a whole lot. We could clean that up to say the integral from 0 to 2 of, it's basically x cubed times 2x cubed would be 2x to the 6th dx. And I can clean it up like that. Because the minus zeros go away and it's just a string of multiplication. So that'd be a lot prettier to type it in the calculator. And that one we would be able to do by hand pretty easily. And stuff on that one, okay? Find the volume of the cross sections taken perpendicular to the y-axis. Same problem, but perpendicular to the y-axis. And notice they said whose height is 6. So we don't have to do 6 times the width. It's just, hey, flat out 6 there. We just now need to rewrite our equations. Y is equal to x cubed. We got to rewrite that as x is equal to the cube root of y. And so I have the integral from 0, and that looks like they're touching at 8. Okay. Now, how could I find what that 8 is if I didn't see that it had a graph? Yeah, we would set when is the cube root of y equal to 2? Is what we would do. We'd set the cube root of y equal to 2. And that would be... Gotcha.
You can borrow that for 2 seconds.
No worries. Anytime. So I would just cube both sides here. And then that would give me my y is equal to 8. So that's how I can find out what my upper bound is set the x equation equal to 2. So then now I have my... all right, so we are drawing them this way. All right, we're drawing them that way. So now this is why what is the right equation? Technically, the right equation is the line x equal 2. So technically, when we look at our equation, it's 2 minus, and then the cube root of y. Okay? It's 2 minus the cube root of y is what I have there. And then now I have to multiply that by the height, which they said was 6th. And then this is the dy. And again, you can simplify from there if you want to, okay? You know, we may not see that as a final version on a multiple choice. We probably see from 0 to 8 of 12 minus 6 cube root of y dy is what we would see there as a multiple choice, or, you know, that's where I would get it to, and then go do math 9 is what I would end up doing, okay? So let's do that. Let's find, oh, I got a calculator built in, that's right. Too many snow days. My brain's not working. All right, so math 9, the integral from 0 to 8, and then it is 12 minus 6, math option number 4, and we'll put an x in there, and then put it with respect to x, and give it a moment, and it gives us that it's approximately probably 24. If we did it by hand, we'd be probably, you know, no matter what, rounded to third decimal is 24. So if we did it by hand, it'd probably work out prettier. So okay. We got one more. Sorry. Any questions so far? All right. Last problem. Again, tomorrow all we got to do is change this stuff and be semicircles and triangles. Is all we're doing different tomorrow. All right, so we got cross sections when you have no graph. Okay, so don't graph it, don't cheat. The graphs of y is equal to x squared minus 4 and y is equal to 2x minus x squared create bounded area that has a base of a solid. Okay. What is the solid that has cross sections perpendicular to the x-axis? That means I don't have to change, and they form squares. Sweet. So that means that I can use the format of from A to B of a side squared dx. I can use that format. That's what that's letting me know. Okay. So let's find our A and B. So when does x squared minus 4 equal 2x minus x squared? All right, well, let's see. Doing some fancy footwork and math. Add that across. Actually, we're going to add and then subtract. So that's 2x squared minus 2x minus 4 equals 0. Divide through by 2, I get x squared minus x minus 2 equals 0. So x is equal, or x minus 1 plus 1, and x minus 2. So x equals negative 1 and x equals 2. So I'm knowing I'm going from the integral from negative 1 to 2 is what I know I'm going. Now, if you don't know which one's on top, personally, that's the one that's on top. Why do I know that one's on top? I didn't even put in the number between negative 1 and 2. Why is that on top? Why is the 2x minus x squared on top? Why can I say that besides putting the 0? Would you say? Yeah, because it opens down. It's a parabola that opens down. And we know this other one is a parabola that opens up. So that's why I know, I mean, I can still put 0 in there. And I can put 0 in there, I get negative 4. I can put 0 in there, I get 0. You can still do that, but again, this one opens down, that one opens up, so the one that opens down should be the one on top. Okay? Unless we're an hourglass. And then now we got, you know, but again, we're at that stage. We're not on this first day. Okay? That's why I didn't say always. Okay? All right, so which one's on top? So on top we would have the quantity 2x minus x squared minus the quantity x squared minus 4, and all of that squared, put in an extra set there, and then dx. Woo! That's the yuckies. Now again, if you want to combine some stuff, negative 1 to 2, I can distribute the negative. So that would be 4 plus 2x minus 2x squared, quantity squared, and then dx. And that would be the cleaned up version. Now, they didn't tell us to find the volume. This one would have to be, I would say have to be, but I would assume this one would be a Math 9, is what this would be. Okay, because they're not going to have you waste the time and multiply two trinomials together, and then take the antiderivative of it, because you don't have a calculator. So now you got to do the antiderivative of it by hand, and then evaluate it. Okay, so they're not going to have it. So this one will. I would wager this. This would be if they wanted the numerical answer, it would be on a calculator section. Okay, just because it's too much to do. Too much to multiply that out, then take the antiderivative of, then evaluate it and put those numbers in it. It's going to be a good, and that's only one subpart of a problem. So it would take you probably about 5 minutes to do it. So, all right.